Hello class, welcome to Unit 4, Lesson 5. Today we're going to go ahead and look at double angle identities. So these identities are located on that solar yellow sheet that I printed off for you. So if you want to go ahead and grab that out, now would be a good time. And just to remind you, it looks like this. And we are going to be using these formulas on that sheet today, the ones that are listed right here. So please go ahead, grab out your your solar yellow formula sheet. And we're going to use that to help us do these problems today. So first thing is, does sine of 60 degrees equal 2 times the sine of 30? The reason we're asking this question is because 2 times 30 would give us 60 degrees. So are they the same thing? So if we're looking at 60 degrees, okay, we would be using our we can use our left hand trick. So remember 60 degrees is right here. So if I fold this finger over, my ordered pair would be 1 over 2, comma, and then there'd be 3 fingers below, so square root of 3 over 2. That is at 60 degrees, okay? So sine is your y value. So this would be equal to square root of 3 over 2. Now if I go ahead and do 2 times sine of 30 degrees, let's do the hand trick for 30 degrees. That would be this finger. If you fold it over, we'd have 3 fingers above, so our ordered pair is square root of 3 over 2, and then there's 1 finger below, so it would be 1 over 2. Okay, and once again, sine is your y value. So we're doing 1/2, so you take 2 times 1/2, which gives me 1. Are these two equal to each other? No, they are not. And so if we ever want to do double angles, there's special formulas we need to use. And here are the double angle formulas. The good news is they are all on this formula sheet for you. Okay, so there they are. So the first one says, find trig values from the given information. They're telling us sine of x equals 1/2 and cosine of y is equal to negative 3/5. So we need to be careful. This is x and this is y. So these are talking about two different ordered pairs. So it says x is in the first quadrant and y is in the third quadrant. So this answer will be positive answers because we're in the first quadrant. And in my third quadrant, they'll be negative since they're in the third quadrant. So let's find cosine of x. Since this is an x, I need to be using my sine function that has an x. And I'm going to use my basic Pythagorean identity to solve this one. I got sine squared of x plus cosine squared of x equals 1. So we've done this quite a few times. So if I plug it in, I will have 1/2 squared plus cosine squared of x equals 1. This is 1/4 plus cosine squared of x equals 1. Remember, I would subtract 1/4 to the other side. You can use your calculator, but cosine squared of x equals 1 minus 1/4, which is 3/4. We take the square root of both sides. These will cancel. And x will equal plus or minus the square root of 3 over 2. Now we are solving the one that has an x and we're in quadrant 1, so I want the positive answer. So my answer would be x is equal to square root of 3 over 2 for part A. Okay, now B says find sine of y. In order to do that, we're going to use the angle that is y. So we're plugging it into here. We'd have sine squared of y plus our cosine squared of y. So I'm going to take it and square it. Negative 3 over 5 squared is equal to 1. Sorry, it's getting a little crowded. So sine squared of y plus negative squared will be positive, and then I'll have 9 over 25 minus 1. Then from here, equals 1, there we go. Then from here I would subtract 9 over 25, which will give me 16 over 25. So sine squared of y equals 16 over 25. I take my square root, and sine of y will equal plus or minus the square root of 16, which is 4, and the square root of 25 is 5. Now, we're in the third quadrant, so my answer will be negative. So sine of y will equal negative 4 over 5. Okay, so these are pretty straightforward. We've done these problems quite a few times now, but we're going to use this information to answer double angle questions. Okay, so by double angle, there'll be a 2 on the inside here. These are just single angle. Okay, got x and y. So we know sine of x is equal to 1/2, and we just solved, and we got cosine of x from the other page. Cosine of x was equal to square root of 3 over 2. Then here we have cosine of y, so then sine of y was equal to, what do we get, negative 4/5. Perfect. So now we're going to go ahead and do a double angle. We have sine of 2x. So if it's talking about x, that means we're going to use the information provided that has the x value in it. So if I go to my formula sheet, sine of 2x right here. This one is sine of 2 theta, same as 2x. So I'm going to write down 2 sine of x, cosine of x, okay? Because in this, the problem we're doing has x's, not theta, so these are all x's. So 2, this equals 2 sine of x, cosine of x. And now all I have to do is plug it in. So I have the number 2. Then what is sine of x? 1/2. Then what is cosine of x? It is square root of 3/2. So then from here, you just solve it. So 2 times 1/2, those actually cancel. I get 1 times square root of 3/2 is square root of 3/2. There is your double angle answer. Okay, let's do cosine of 2x. If I go to my trig identity sheet, there is actually 3 different options. No matter which one you do, you will get the correct answer. Okay, so it doesn't matter which one you do. Let's just do the top one. Cosine squared x minus sine squared of x. You could do any of them though. So cosine squared of x minus sine squared of x. Then I would go ahead and plug in. Well, what was cosine of x? Right here, square root of 3/2 squared minus my sine of x squared, so 1/2 squared. This will equal, the square root of 3 squared is 3, over 2 squared, which is 4, minus 1 squared, which is 1/4. So common denominator, so I can put my numerators together. I'll have 3 minus 1, which is 2/4, which reduces to 1/2. Okay. Then the last one on this page is sine of 2y. Okay, so sine of 2y. So I'm going to use my double angle formula for sine. There's only one, so it's got to be sine. We're doing 2y, so it'd be sine of 2 sine of y, cosine of y. Let's get a color here. There we go. So we got 2 sine of y times cosine of y. So now all of this stuff deals with y, so I'm going to use my y values. Okay, so my y values will have 2. Sine of y was negative 4/5, and cosine of y was negative 3/5. So 2 times, this is really 2/1. I don't see anything that's going to cancel. So we'll have 2 times negative 4 times negative 3. So it's going to be positive. 2 times 4 is 8. 8 times 3 is 24. Then we have 1 times 5 times 5, so 25. Our answer is 24/25. All right. Next question. Since sine of 60 degrees does not equal 2 sine of 30, what does sine of 60 degrees equal? Well, we know what it equals based off of our hand trick from earlier. We know that sine of 60 degrees was equal to square root of 3/2, and you can do that by your hand trick. But I want to show it using a double angle formula. Okay, so I'm going to prove that it equals square root of 3/2. Well, that line got a little crooked there. Okay, double angle formula for sine of 60 degrees. So I would say to you, sine of 60 degrees is really equal to sine of, I need to have a 2 on the inside. So if I have 2 times 30 degrees, that would be my double angle. Okay. So the equation was sine, getting it off of your sheet, was 2 theta equals 2 sine of theta cosine of theta. So if I'm proving it, who is my theta in this case? 30. Okay, so 30 is my theta. So wherever there's a theta, I'm going to write 30 degrees to solve this problem. So it will equal 2 sine of 30 degrees times cosine of 30 degrees. So if I go back to our hand trick, well, if you do the hand trick, it would be this finger right here. So it's square root of 3 over 2 comma 1. Okay, if you fold it over. So I'm going to write down my ordered pair using my hand trick. So, whoops, that got a little mark up there, sorry. So my ordered pair at 30 degrees is the ordered pair. Square root of 3 over 2, comma 1/2. And my sine value is my y value, so I will have 2 times 1/2 times my cosine of 30, so square root of 3 over 2. Okay, these will cancel, and I will be left with square root of 3 over 2. There is my answer using my double angle. Okay, so this one might not be very helpful, but let's say, I'm trying to think who we could do. Well, we'll see it on the next page, I guess. So let's go ahead and do that. So simplify the expressions using the double angle formula. So I see this and I'm like, what angle was this originally? So I know that sine, it's right here, sine of 2x is equal to 2 sine of x cosine of x. So who is in the spot of x? 35 for this one. So this is really sine of 2 times 35. Well, 2 times 35 is 70. So this is sine of 70 degrees. That is who that is equivalent to. This next one, I notice it looks like this formula, so it's going to be sine of 2 times 22. So it was the double angle broken down, so it's going to be sine of 44 degrees. Okay. So that's how we can go backwards. So if I have it plugged into my double angle formula, how I could go back to what it started out to be. All right, to the next one. Simplify the expression using the double angle formula. Okay, so in this case, we have tangent of 2x. So I need to figure out, well, who is my x in this case? Okay, so my x is really all of it. It is 5x. See how it's taking the spot there? So to go back, it would be tangent of 2 times what is the x? 5x. So this is tangent of 10x. Okay, so that's who this is equivalent to. Take a second, pause the video, maybe try the next one on your own. But hopefully you tried it. So who's on the inside here? It is tangent of x, and this is also x. So x is equal to 13x, so we have tangent of 2 times 13x. So it is tangent of 26x. There it is simplified for my double angle formula. Okay. That is it for our notes today. Your homework is a worksheet. I'm sorry, I'm just going to really quickly pull it up. Why did I go to Unit 6? We're in Unit 4, Lesson 5. Okay, so these ones are just finding using your basic Pythagorean identity. Find the other pair. Ooh, I pulled this up wrong. This stuff is from 4.4. Okay, cosecant of y. How would you guys find cosecant of y? You would just do 1 over sine of y. Okay, so 1 over whatever your sine of y value is, which you'll find up here. So you're going to use this information to do all of this. Tangent of x, you would do sine of x over cosine of x. Then here you'd use your double angle formula. Here, double angle formula again. And then repeat the process. Okay, and this is the going back part. So, should be okay. If you have any questions, let me know. Otherwise, have a good day, and I will talk to you later.